In this lecture, we'll discuss string streams. A string stream is an object that is associated with a standard string. Okay, so previously we looked at file streams, which we then associated with a file, but a string stream is associated with a standard string. Once associated with a standard string, characters can then be inserted or extracted from the stream. This is useful in many instances. You can start to think that we can do data validation, we can extract and insert in a familiar way as we did with file streams. So this opens up some additional possibilities and ways for us to manipulate and work with character sequences. Alright, so the classes that we will discuss here include the string stream, the iString stream, and the oString stream. The string stream class is similar to the fstream class with file streams in that we can use a single object to insert and extract, so it can go both ways with the string stream class. With the iString stream, characters can be extracted, and then with oString stream, characters can be inserted. So this is similar to what we've done previously with file streams, but again here we are working with string streams. What are the steps that we need to follow when we want to use string streams? Firstly, we need to include the appropriate file, so we will include sstream. Then we want to instantiate the appropriate class, so string stream, iString stream, or oString stream. As I discussed with the fstream class in the file stream section, it is best to use a specific class for input and output, so instead of using string stream, I prefer to use iString stream or oString stream. So we will instantiate the appropriate class, then we will connect or associate the stream object with a standard string, and then we will insert or extract from that stream. In this example, I'm not using a file, so I'm not going to include fstream. I'm including iostream, I'm including this sstream for string streams, and I'm including string. Then in the main function, I go and instantiate a string. I'll just name this player stats, for example. And in the string, I have the name of the player and then the level for that player. Just as an example, you can also do a person's age or whatever it is. Then next, I instantiate iString stream, ISS. I call this ISS for iString stream. I initialize that to player stats. So notice here that we pass in the player stats string instead of some file name. Next, I have another string here, player name, and then player level. Finally, I want to print out the player name, ears level, and then the player level. Of course, again, you can do something like a person's name and then their age. But in this case, I'm doing player name, player level. So what we want to do is we want to get or extract the player name and the player level from this stream. Again, this stream is connected to the player stats string, and that player stats string has these two things in here. So here on line 13, I want to write some code, and I'm actually going to leave this as a quick exercise for you to attempt to write the code that is going to extract that data, because again, we want to print that out right here. Alright, so just a quick test on your knowledge on streams. Pause the video and give that a try. Write the code that will extract that data. Alright, I'll just continue on here. From the ISS, so the input string stream, we want to extract some data into what will go first, the player name. Next, we have the player level. Okay, so we can extract as we could with the cin stream. In this case, we are using a string stream. Alright, so we are extracting these two things. Remember that the extraction operator will stop, so that operation will stop when it sees white space. And then it's going to extract the next thing again. So we extract the player name and then the player level. Build and run. Alright, we get Bob is a level 47. So with this, we can see that we have successfully extracted the name and the level. So basically this string and this string right here, we have extracted into a string and into this integer respectively. And you can already start to think how this can be useful for data validation. So of course, instead of using the iString stream, we could have used the string stream here, because this goes both ways. We can extract and insert into a string stream. I'll just remove the I here, so we have SS for string stream, like so, and this should work fine here. Build run, and we get that string printed out. Bob is level 47. But I will actually undo that, because as I mentioned before, I prefer to use the more specific class, so depending on whether I want to do input or output. So in this case I will do I string stream because I want to extract from that. A quick demonstration to emphasize the buffer that you may have with a stream. So in this example I just have the string here, player stats, and I prompt the user to enter the player name followed by the player level. Then I have the player name and the integer for the player level. I do standard cin player name. Then I actually print out the player name. But then I do standard cin player level. And then I go and print that out. So player level, player level. So you can think for a second what's going to happen when we build and run this. If for some reason I only enter the player name and I press enter, then we get the player and Bob, but you can see that execution has stopped here because we have to enter something. So enter some value, 44 for example, press enter, then we get the player level is 44. Build and run again if I enter the values correctly, such as Bob, space and then 47, press enter. Then I get the output, the player Bob, and the player level is 47. So notice when I enter correctly, we don't get another chance to actually enter the value. It is as if it is stored within cin, right? So it does standard cin player name. It's going to extract the first part of that string that we've entered, the player name in our example Bob. Then it's going to do this output statement. But then it's going to do the standard cin again, and it's going to extract the player level from cin. That is from the next part of the string. Remember, the operation is going to stop when it reaches the space. So this operation here is going to stop when it reaches the next space. Then we print this out, and then we do standard cin again. I'm deliberately not doing both on the same line here. I'm not doing cin player name, player level. Alright, I'm doing player name, printing this out, and then I'm doing cin again. So why does this work, right? Well, cin has a buffer basically. It stores those characters that we have entered, and then we extract those. Later on we will look at how we can discard any remaining characters that we are not interested in keeping in the buffer. You can already start to think how you can do that with something like getLine, for example. But here's another function that I will introduce that we have not talked about yet. So the point I want to emphasize here is that cin basically has an internal buffer. Now with cout we have seen how we can flush that. But with cin we have to sort of extract those characters in a different way if we want to get rid of the remaining characters. Alright, so just a bonus demonstration on this. We have talked about get previously and how to extract characters from the cin stream, such as with the new line that is left behind when we want to do getLine, for example. We've talked about those things before. So hopefully this gives you a better idea. Again, cin essentially has a buffer and it's going to store what we've entered, and so later on in the program we can actually still extract from the cin stream. That is, we can extract the characters that remain within that stream. Back in your previous example, it's the same thing with our string streams. The string stream has a buffer internally, and so we can do the extraction in this way. I would like to note that this does not actually modify the string that we associate with that string stream. So for example, if I copy this console output statement here, and we print out player stats, string right here that we have associated with the string stream, you will notice that if we build a run, Bob is 47. Okay, we have not modified that string. The string stream is going to keep its own internal buffer containing those characters, as we have just discussed with the cin stream. Alright, so that is a quick look at how we can do the association with the string stream and a string, and then how we can extract from an I string stream. Next we want to look at how we can insert into a string stream as well. So for this next example, we want to see how we can write out to an output string stream. So I have an output string stream which I'll name OSS, and then I use the stream insertion operator, and we can insert a string, and then we can also insert an integer, for example. So a few things that we can notice with this. Firstly, I do not pass in a string as we did with the input string stream. Secondly, again, as I discussed in the previous subsection, these string streams have an internal buffer. So it is going to keep the string in an internal buffer. We do not have to associate a string with the output string stream. So how do we now fetch or return the string that is within that internal buffer within the output string stream? Well, we can use an str member function. For example, I will do a console output, cout, and I will put in the result of this. This .str member function is going to fetch the string. Alright, so I will build and run. We can see that it will fetch that player Bob is level 47. I'd also like to note that you can actually use a different version of this function. So we have two versions. One will return the string as I mentioned, but the other overload will return void. Then it's actually going to take in a string, so we can use that function to modify the contents of the stream. For example, something like that. Output string stream.str, and I pass in the string that I want to have be stored in the internal buffer of that output string stream. And finally, I will print that out again, build and run, and you can see that has modified the stream, the contents of the stream. Alright, so that is a look at how we can use the OString stream and write to and insert into that stream. Very useful if you want to piece together multiple pieces. So you can have different things here. You can have a string and a variable and so forth, and you can build up a buffer, and then you can eventually put that out into a string, or you can simply access it in this way instead of having to try to modify a string object. One use case for the string streams is user input validation. For this example, I'm including IOStream, SStream, and string. Then in the main function, I have some string user input, some integer to catch a number, because we want to make sure and validate that the user has entered an integer, right? I have some boolean for this. Here's input valid. I set that to false initially because we have not entered any and validated any input yet. Next, we enter a do while loop since we want to execute this code at least once. Do, please enter an integer. I do cin user input, stores that into that string. Then I'm declaring this variable here, iString stream, ISS, and I associate that with the user input string. You may want to use the str member function with this. As I described previously, you can also use that with the iString stream. However, for some reason that will not work as intended with this example. There's some sort of bug with that and it will not perform the check properly here. Next, we do the check. Now we can actually perform this sort of check here. We extract from the input string stream into num. So if that is successful, then it will enter this block right here. I print something out, the integer is num, and then I set is input value to true. If this fails, then we enter the else part and we print out incorrect input, please try again. Because this is going to loop in this case, I will discuss this line here shortly. While the input is not valid, this loop is going to repeat. So let's build and run this and see what we get and look at some of the issues that we can have with this. So if I enter some integer, 55 for example, press enter, we get the integer is 55. Okay, so this here works to check if that operation, the extraction operation, is successful. If that extraction operation is not successful, then this is going to fail. Okay, so let's look at an example of that. And I'll actually enter two things here. I'll enter some string followed by an integer, alright? Press enter. Now this is the sort of issue that you can run into. We get incorrect input, please try again. That extraction failed, so that if check failed. But then we don't get the opportunity to enter another integer again. We don't get the opportunity to enter something again. because this is going to jump to please enter an integer, and then we get the integer is 55. Right, so this comes from the discussions in the previous subsections where I mentioned that the CEN stream will have that entire string here in a buffer. And when we try and extract this first string part here into the integer, it's going to fail. But then we still have the 55 left in the buffer. So next time it's going to read that. One way of solving this issue and allowing the user to actually enter something again is we can do that in two ways. Firstly, I'll just paste in some code here. This is something that you may have thought about doing. You can discard the rest of the characters in the CN buffer. In this way, we can have some string and then we can get the line CN discard up until the new line character, right? So it's going to read all of that and put that into some string, for example. Build a run. Enter some string followed by an integer. It's not going to simply read that first part, fell, the while loop is going to repeat, and then it's going to extract the next part, so 55, because that is left in the buffer. Instead, it's going to discard the rest, and we now have to enter something again. The integer is 5, so that works. I'll actually comment that out, and we will use this line here. Now, because we use numeric limits, I want to go and include the limits file. Alright, so I'm also including the limits file now. So we do standard cen.ignore, the member function ignore. We pass it the amount of characters that we want to extract and ignore. So how do we find the maximum number of characters? Well, we can use the numeric limits. This max here will give us the maximum value for a particular type. And the type we are looking at here is actually the stream size. So you don't pass in integer or float or something like that. We pass in the stream size. We get the max value for that. And we are going to use that number, and we are going to ignore that up until the new line character. So ignore all of the characters that are left in the CN stream up until the new line character. Build a run. So we try to enter something invalid again, and as before with our get line, we can now see that we have the opportunity to enter a value instead of it extracting in the second iteration of the loop. So we can enter a value now, 35 for example, enter, and that works. Build a run, and of course if you enter correctly it should also work. So that is another way of doing user input validation using the string streams. Alright, so I hope you find this interesting and useful moving forward, and I will see you in the next lecture.